Hey guys, so what we're going to be doing is for math, we'll be making some review videos for the next few weeks, not over spring break, but just to kind of refresh our minds on some of the things we did early in the year, and also just quickly introduce us to some things that we're going to get to in more detail later, but kind of just get that stuff so you're thinking about it so you have at least a little bit of knowledge about it. So what we're going to do this week is we're going to go back to some scientific notation, then we're going to also do some exponent rules. So let's start with the scientific notation. And so scientific notation is for really, really big or really, really small numbers. And so one thing about scientific notation, the number always has to be one digit, 1, 2, 3, 4, 5, 6, 7, 8, or 9, and then you're going to go times 10. So this first one, there's going to be one digit. We're going to end up putting a decimal between the 3 and the 6. So the number is going to turn into, it moved from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're always going to have one number, the decimal, and then the whole, or the number that's after it. If it's a bunch of zeros, we would just leave it. So 3.6 times 10 is always going to be times 10. It was a number that's bigger than 1, and it would happen to be 10 times moved over. So 3.6 times 10 to the 10th, meaning to get back to it, we would do 3.6 and we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'd fill all of that with zeros, all those little empty spaces. Okay, there should be the same number of zeros as before. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not 10 because that 6 took up one of the little loops. Okay, so the next one, let's change the color so we can differentiate. We want one number to the left of the decimal, so it's going to be 4.27. It's going to be times 10, and it's going to be a negative because we're going to have to move to the left. So I'm going to go to get back there. So 1, 2, 3, 4, 5. Negative 5. Okay, so then this next one, let's change the color again. I'm just going to keep changing the colors. It's going to be 2.0, but I can just write 2 times 10. That's always going to be times 10. 1, 2, 3, 4, 5, 6, 7, 8 to the 8th power. Okay, let's go back to black. The decimal is going to be right here. Okay, so it's 9 times 10 to the 1, 2. It's negative because that number starts out less than 1. And then the next one, it's going to be a negative. So I'm going to put this times 10. It's going to negative. Oh, I didn't change the colors. It's okay. And it's going to be 5.1. It's going to be between those. So 5.1. That's bad handwriting, sorry. Times 10 to the negative 1, 2, 3, 4, 5, 6. Negative 6. Okay. This very last one's a little bit tricky because it's already in scientific notation. So I could leave it as 1.2, but if I want to put it officially in scientific notation, it's times 10 to the 0 because I'm going to move it 0 times. So now remember, this is just a review, so you can actually pause this video at any moment, try the problem, and then restart it again to see if your answer is right. If you need more practice, you can get a hold of me and I can try and help you find some, or you can actually look on the internet for other practice for this types of things like standard notation to scientific notation. So to fill this in, if I'm going to scientific notations, that's what I was just doing the last slide. I'm going to put a decimal here. I'm going to go 1, 2, 3, 4, 5, 6. Okay, so it's 7 times 10 to the 6th because I moved it over 6 times. Okay, now I didn't have a decimal after that 0 originally, but all numbers have a decimal at the end of them. If there's nothing on the other side, we don't have to put the decimal. So now check this one out. If it's 4 times 10 to the negative 5th, I'm going to put my 4. I'm going to start here. I'm going to go 1, 2, 3, 4, 5, because that negative means you're going to go left. Okay? So I'm going to fill in all the zeros for all the empty little loops and put my decimal here. Notice there's 4. When I go that way, it's always going to be the same number of zeros. It's always going to work the same. It was negative 5, okay? but there's 4 zeros because I had to get past that 4. So we can show you on this one. Let me change the color so we can kind of differentiate again. This one is going to be 1.39 because I need my decimal right here, one number to the left, and it's going to be times 10 to the 1, 2, 3, 4, negative 4. Remember, you can pause at any point. Look at this next one. This next one, I'm going to go 3.2, and it's a positive 4, so I'm going to go 1, 2, 3, 4. I'm going to fill in those with zeros. So if I were to write this, I'm going to be careful when I show my work on this, because I would just write it as 32,000. Okay, when I put those little loops underneath it, some people think that's 2 decimals. There's only 1 decimal in a number. If I really wanted to include it, I would put it right here, but I don't have to. Okay, let's look at the very last one. It's going to be, there's a 9 here, but it's okay. Let's make it 4.2. It's rounding. Okay, and I'm going to go from here 1, 2, 3, 4, 5, 6, 7 times 10, and it's to the positive 7 because the number itself started out as bigger than 1. Okay, so I'm going to throw one really quick at you. I'm going to do another negative one. Let's just do like 7.2 times 10 to the negative, let's go to the negative 8th. Okay, try that, then restart it. So if I were to do that, I'm going to put my 7.2, and I'm going to go negative, it's to the left. Okay, so I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8. My new decimal right there. I'm just going to fill it in. There should be 7 zeros. 7 because I had to get around this 7. That's just a coincidence right there because that's my new number. There's no decimal right here. That's gone. Okay. When I write it again, I would write 0 point. I don't know why I put that 0 there. Just kind of identify it. Then my 7 zeros. 7, 2. Okay. Okay, so I'm going to speed this one up a little bit. You can pause it and try and figure these out. So I extend it all to, personally, extend it all to standard form when the numbers are this small. And then I put it in order from smallest to largest. There are some things we can do to cheat when we put it in least to greatest, knowing that the 2 smallest ones are going to be the ones with the negative 5s, right? And then the biggest one is probably going to be the 4.2 times 10 to the 5th. So here's what I did. So you can pause it and try it. I'm going to actually, I already wrote these out. Look at that, like I planned for that. And then I can kind of compare these. And so the smallest one, I believe, is this one right here. Because it's 1, 2, 3, 4. The 5th one's a 1. This is 1, 2, 3, 4. The 5th one's a 5 because I can put a 0 and that's 500. So that's bigger. So my smallest one is 1.08 times 10 to the negative 5th. So I'm going to put a little check by that one. I already did. My next one is 5 times 10 to the negative 5th because I'm least to greatest. Put a check there. And then these are all numbers bigger than 1. It makes it a little easier for me. And so I'm going to go 1400, so 1.4 times 10 to the 3rd. That one's gone. And then 6.3 times 10 to the 4th. And then 4.2 times 10 to the 5th. All right, and then that's it from least to greatest. Okay, so this is really quick, you guys. So this is just a quick introduction, just kind of talking about if I had to multiply scientific notation. It's kind of like distributive property, but you're just multiplying the like terms. So check this out. So you're going to multiply, so it's actually more like multiplying like terms. The 9 times 1.9. If you multiply that, you get 17.1. And then when you actually multiply 10 to the 5th times 10 to the 8th, you actually get times 10 to the 13th. Now we have a little bit of a problem because there's supposed to be only one number to the left of the decimal, and there's 2. So we have to move it. So it's going to be actually 1.71 times 10 to the 14th. You can also mess with your calculator and see if you can enter scientific notation, and it'll give you that answer too. But it's just something to think about. When we're multiplying with exponents, we're actually going to add the exponents. So let's talk about division. And you're going to actually you're going to actually subtract them. So first thing is 9.6 divided by, this line right here means divided by. It's like a fraction. Okay, 9.6 divided by 1.4. Not so pretty. It kind of goes on for a long time. So I'm going to round it to 6.86. And it's going to be times 10. And we start with 12, and division is going to be subtract right here. Minus 7 is 5. 6.86 times 10 to the fifth. So that's pretty tough. Those are pretty confusing. But if you just do the computation, multiplication, or division to the number in front of the times 10, do that, and then you're going to, if it was multiplication, add the exponents, and if it's division, you're going to subtract the exponents. So when we talk about integer exponents and exponent rules, this is kind of going to go along with what we just did on the last slide. It kind of solidifies that. So if you have 7 to the third to the fourth, what that means is you're going to take 7 to the third, and you're going to do that 4 times. So what I always tell my students is, if I'm confused, I write it all out. Okay? And now I could even go further and say 7 times 7 times 7, that's my first 3, times 7 times 7 times 7, that's my next 3. And you guys get the picture. Okay, and I'm going to do that 4 times. And then to simplify that, it's going to be 7 to the, it looks like 3, 6, 9, 12th power. So ultimately, I just multiplied the 3 and the 4. Okay, so be careful with that. So this 3 to the second times 3 to the fourth times 3, let's make that to the 1. I could write it all out, 3 times 3, then 3 times 3 times 3 times 3 times 3, right there. Or I can just add these up. 2 plus 4 is 6, plus 1 is 7, 3 to the 7th. Okay, so let's put parentheses around this one. So then this one, when we have division, you actually subtract. So let's try this. So 7 squared and 7 cubed, that's 5 sevens. And then we have a 7 to the 9th on the bottom. Okay, so let's do this. Let's write this out. So I have 5 sevens, 4, 5, and I have 9 sevens on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. And every pair turns into 1, so I can cross those off. And I'll cross them off that way. So it looks like I have 4 sevens left. So my answer becomes 1 over 7 to the fourth, or, that's a 7, and the 4 is in the exponent, or 7 to the negative 4, because 5 minus 9 equals negative 4. So here's my last one. So remember, when I'm multiplying, I'm adding the exponents. The base has to be the same. The base in this case is 8. When I'm dividing, I'm going to subtract exponents. So I could do this. I could say 2 minus 6 equals negative 4. So my answer becomes 8 to the negative 4th. I could also do this and go 8 times 8 over 8 times 8 times 8 6 times. Okay, and I can cross out my pairs. That leaves me with 1 on top, and then 8 to the 4th on the bottom. Same thing as 8 to the negative 4th, because when I say negative 4th, I'm actually going to put that exponent in the denominator. So I'm going to make it 1 over 8 to the 4th, same exact thing. So I can give you more practice, just a quick intro. I know we went over a lot in this almost 15 minutes, but I can give you practice as well. All right, thanks guys, and I'll send more after spring break.